The law of sines is if you have a triangle, it does not have to be a right triangle, but if you have a triangle ABC where A, B, and C represent the side lengths, angle A is opposite the side, angle B is opposite side B, and angle C is opposite side C. So the sine of A is to A as the sine of B is to B as the sine of C is to side C. So you can break apart any of these. You can use these two as a proportion. You can use these two as a proportion. So angle A is always across from side A. Angle B is across from side B. Angle C is across from side C. So you have to carefully draw your triangles. So I'm going to draw a triangle KLM. K, and it's not drawn to scale, is 120 degrees. M is 50 degrees. And then the segment ML, so it says L, this segment ML, or the distance between M and L is 35 yards. So this 35 represents little k. This side right here would be little m. This is lowercase l. So if I'm trying to find KL, I'm trying to find the side like the M. So I'm going to use the angle that's across from M. It's 50 degrees. So I'm going to do the sine of 50 degrees is to M, and I'm going to use the side and the angle that I know. Now I do know this angle because all three add up to 180. But I don't know this side length, so that's not going to help me with my proportion. I only want one variable in here. So I'm doing the sine of 50 is to M as the sine of 120 is to 35. Now to solve this, I have a proportion. So what I'm going to do is I'm going to cross multiply. So I'm going to write the 35 sine of 50 equals sine 120 times M. So this right here is just a number multiplied by M. So I'm going to divide both sides by the sine of 120. So this cancels out. So M equals all of this. So I'm going to put this in my calculator. I'm going to put the numerator in parentheses. So you get this answer in your calculator. I don't have my calculator right now. So in example 2, I'm going to draw a triangle PQR. Doesn't matter how I draw the triangle, as long as little r is going to be across from big R, lowercase q is across from uppercase Q, and lowercase p is across from the angle P. So I need to label 97.5 as angle R, side length R is 80, side length P is 75. So I'm trying to find angle P. So angle P is across from side P, so these two need to stay together. I'm going to use these two in my ratio. So you always put the sine with the angle. I'm trying to find the angle. So I do sine of the angle P, which I don't know, is to 75, which is the side, as sine of 97.5 is to 80. So again, I have two ratios that are equal, so I'm going to cross multiply. So I'm going to do 80 sine of P equals 75 sine of 97.5. So to solve for P, I need to first divide by 80. So I have sine of P equals all of this. So if you remember back in chapter 8, if you have an angle, you're trying to find an angle. So when you try to find an angle, you're going to use inverse. So in my calculator, I'm going to do sine inverse, so I do second sine of all this, and I'm going to get an angle measure. And then here's an application of this. So two observers view the same mountain peak from 2 points on level ground 2 miles apart. The angle of elevation for the observer most distant from the mountain is 31 degrees. For the other observer, the angle of elevation of the peak is 58 degrees. So somebody stands right here and they see 58. Somebody stands right here and they see 31. Find the distance from T to the summit. So the summit is up here. So you're finding what this distance is, T. So actually that's kind of confusing because this looks like little s. So we'll call that s actually. So I know that this is 58 degrees, but I'm looking at this triangle right here. And I know I'm going to put these two angles together. I'm trying to find side S. So this angle right here is not 58. This angle right here is 180 degrees minus 58. So this angle is 122 degrees. So you're going to do sine of 122 is to S as the other angle that I have. Well, I have this side length right here. I have 2 miles. That's the only side length I have, so I have to have 2 miles. But at 2 miles needs to match up with this angle, K, right here. I don't have that angle either, but I can figure that out by doing 180 minus 58 minus 31. That angle is 91 degrees. Gosh, is that right? Doesn't look like it. Oh, never mind. Wait, I know what I did wrong. I used 58, not 122. So it's 180 minus 122 minus 31. So it's 180 minus 153, which is 27. That makes more sense. So it's 27. So I'm going to do the sine of 27 is to 2. So you always need to have a side and an angle across from each other that are known in order for you to do the law of sines. So now I'm trying to find S, so I'm going to cross multiply. So I write this is S times the sine of 27 equals 2 times the sine of 122. So the next step I do is I divide by 27, sine of 27. This cancels out. I don't have to do inverse because I'm not trying to find an angle. I'm just going to do 2 sine of 122 divided by sine of 27 to get my answer.